Anything that really you want to go over? And it can be from anesthesia, pharmacology, surgery, you know, anything from the beginning to now.
Probably like solutions are what I like struggle with.
Okay. Yeah, absolutely. Anybody else? Blood gases. Yeah, so blood gases are definitely an interesting one, especially if you didn't learn about blood gases in school, right? So some people didn't actually do a lot with blood gases. So that can be an interesting one. So who hasn't learned about blood gases in school?
I haven't.
Okay. So that might be a good one for us to go over. All right. Yeah, so quite a few of you. All right, so we'll go over that. Sorry, I just, what else are some things that you may not have, or what else are some things that you would like to go over? Anyone? Anything else? How'd you guys do with surgery instruments? We're not quite at radiology yet, but yes, we will get to radiology for sure. Radiology is always a troublesome area for a lot of people. So.
Could you go over like the concentrations, like the formula C1 and then like C2 and all that?
Absolutely, absolutely. We'll definitely do that. So yeah, perfect. Yeah, we'll go over all of those. So I have a lot of math ones for you guys, some ECG things too. And then yes, blood gases we'll take a peek at. So yes. So for the drug schedules we talked about. All right, I'll double check it on Moodle and make sure, I'll make a note of it really quick so that I can make sure to find it for you. Yeah, so blood gases, I just teach you guys basically the very intro level to blood gases. And then we'll get to blood gases. So we'll do that first. But then there's always going to be more to it. So it's a very, very intro level. So let's talk about that first. So I'm going to share my screen with you guys. And so when we talk about blood gases, we are essentially looking at a few things. So we're evaluating essentially first the animal's blood pH, right? So what is the animal's normal blood pH?
It's 7.35 to 7.45.
Good, 7.35 to 7.45, right? So a normal, neutral pH is what? Like a good 7, right? So like if we're looking at like a scale or whatever of determining neutral versus like an acid base, neutral is 7, right? So typically blood is actually more alkaline than on a neutral level. But when we are looking at blood itself and determining what is acidotic versus alkalotic, essentially, if it is less than 7.35, so if it's going this way, then that's going to be what?
Acidic.
Okay, so it's going to be acidotic, right? And then if it's going this way, it's going to be what?
Alkalosis.
Alkalotic, whatever. Spell it wrong, alkalotic.
Can't say it.
Whatever. Okay. This is an L. Okay, I don't know, whatever. So it's too early. So that is the first thing that we look at, right? So then the second thing we are going to look at is this animal's HCO3, right? So what is that?
It's the bicarbonate.
It's the bicarbonate. Very good. So a lot of people term it as bicarb, right? But it's the bicarbonate, right? So where does the bicarbonate or bicarb originate from? Where does it come from?
I know it's the metabolic aspect, and I know it's base.
Good. So it's metabolic, but it's coming from our kidneys.
Kidneys. Okay.
So that's where it comes from. That's where it becomes our metabolic aspect, right?
Okay.
So that's our bicarb, right? So HCO3. So what is our normal range of our bicarb?
18 to 24.
Okay. So this is kind of where our weird range is. It's actually 22 to 26.
Oh,
Yeah. It's okay. Some people say a little bit different, but yeah, it's actually 22 to 26. And this is millimeters of mercury. Okay. Now, that one you just have to like memorize. So, but this next one is really easy to remember. So our next one that we have to know is our what?
Partial CO2.
Okay, so I just put CO2 to make it easy for you guys, right? So what is the normal range for our CO2? Oh, good, 35 to 45, very good. So 35 to 45 millimeters of mercury. So that one's easy to remember because just look, 35 to 45 right there, right? And then you have 35 to 45, right? So this guy, your CO2 comes from where?
The lungs, the respiration.
Yeah, so it comes from your lungs. So therefore, that's your respiratory component, correct? Perfect. So how do we determine what is what, right? So the first thing we look at is if our pH is out of whack, right? So our pH is, say, 7.47, okay? That's the first thing we're going to look at and say, okay, it is going this way. It is going, sorry, it's going this way. So it is going to be
Alk.
alkalosis, right? And then say our, then our second part is going to be we're going to look at our bicarb. Say our bicarb is 24, right? HCO3. Our bicarb's 24. And our CO2 is 49. So we look at our bicarb is normal. So it can't be then metabolic because our metabolic is normal, right? Yeah, look. And so whoever's the issue is then going to be the problem. But we first look at our bicarb, okay? So then since it's respiratory, then it becomes our respiratory alkalosis. All right. Now, I gave that to you as a very, very simple explanation.
Mhm.
Okay. Now, when we get to the point in animals where some of these numbers are going to vary, and it can be really out of whack because people go, well, Beth, what if they're both different and whatever? It's called compensation. So you'll see sometimes where especially like a DKA comes in and they're coming in and panting a lot and people are like, oh, they need to go into oxygen because they think they're oxygen dependent. What they're not, they're actually compensating because they're trying to, because they're so metabolically acidotic, what they're trying to do is they're trying to bring back their blood values back to this normal range by breathing out all this CO2 and switching everything back up. So the body tries to compensate itself. So sometimes you'll see these out of whack. So I give you guys just the very basic of this so that you have a clear understanding of what this all means, because acid base can be very complicated, but it's good to not shy away from doing acid base because people get very intimidated by it, even though the very simple explanation of it can be really easy. So because yeah, I always say the odd one is the winner here. So you just have to first evaluate your pH and then look at these two guys and say, okay, well, who's the odd one out? And that one is the winner for your respiratory or your metabolic. Does that make sense? And then when you get really good at it, then you can take on the compensation factor. And then your patients, when they're super sick, they'll throw an oddball at you and, and then it still becomes really weird. You good? You want to try another one?
Yes, please.
Yeah? Okay. So let me erase this. So I'll leave this guy up here. So we have 7.24. HCO3 is 19. CO2 is 37. So do it first in your head and then we'll ask. Awesome. So what'd y'all get? Good. Metabolic acidosis. Very good. So yeah, so this is acidotic because it's going, sorry, the pH is going, well, I shouldn't make that arrow there so that you don't get confused. It's going this way, right? So it's acidosis. And so our bicarb is also going this way, right? So it's metabolic. And this guy is within the normal range, right? So he's all right. So it's a metabolic acidosis. Very cool. Good job. Any questions on that? Let them marinate for a bit. Retry those other ones. See how you do. Great. All right. So let's go to this one. Okay. Here are some that I just picked up that I thought you might need some help with. And correct me if I'm wrong. So, so some mill equivalent ones. Let me just get my chat back. Yes, so there are times where there are the bicarb and the CO2 are out of range at the same time. Yes, and so like I was talking about before, that's usually a compensation one. So I'm not going to get into detail about that right now because I just want you guys to kind of handle just kind of dealing with the basic concept of it as of right now. So I'm just happy that you learn about acid base at the moment. So you guys are instructed to add potassium chloride to a 350 ml bag of plasmolite with a concentration of 44 milliequivalents per liter of KCl, and then your stock solution is 20 milliequivalents per 10 mils. And then, so how much in milliequivalents will you add to your 350 mLs? And then what's the total volume that you add? So how are you guys going to set this up? Okay. Got it. So you guys want to do C1 times V1 and C2 times V2. Okay. All right. So you want to do, so how are you going to formulate that? You guys tell me. You'll do your boxes here, right? And so where are you going to put everything? Okay. So if you had, so the 44 milliequivalents per liter. So think about what you currently have, right? So you currently have 350 milliliters, right? And you are trying to figure out how much milliequivalents that you're going to have to add. So that's the concentration, right? So we don't know that part, right? But then your doctor wants 44 milliequivalents per liter, right? So if you put 44 milliequivalents and then the liter, we have to change to mils because we're in mils over here. So you just put 1000 mLs there. We can probably do it that way, right? So what's 44 times 1000? 44,000 equals 350. Well, I guess you just do 350x. X. Yeah. That's the condensed or simplified, I should say. Make sure I'm not losing anyone here. Hold on. Does that make sense so far? And then if we then simplify that more, right, we're going to divide by 350 on both sides. And we get what?
125.7.
Okay, 125.7 MEQ. So that would be if you guys wanted to do that as a C1V1. So I don't think that's going to work for us that way. But good news, we can do something a little different. And I say we can't do it that way because 350 mils is a lot less than 1,000 mils. And we end up getting something very much greater than 44 milliequivalents. So there's two ways you can do it. So you can either do it by doing 44 milliequivalents over 1,000 mLs, which then you equal 350 mLs over X and figure it out by cross multiplying. You can do it that way and simplify it, or the easiest way is to take your 44 milliequivalents and solve it for, rather than 44 milliequivalents divided by 1,000 mLs. Figure out how many milliequivalents you need for 1 ml that he's asking, right? Or she is asking. So for 1 milliequivalent, it would be 0.044 milliequivalent per ml. And then you just take that and multiply it by whatever you have that you need times 350 mLs times 350. And you get 15.4 milliequivalents that you need. It's a lot less math. Does that make sense? So that gets us the first answer. Yeah, the extra is confusing sometimes. Exactly. All right, so the concentration of KCl. So they do this sometimes on the bottle of KCl, which drives me nuts, right? If anyone's ever looked at the KCl concentration. So that's why I put it in there. So they do 20 milliequivalents. Ooh, I can't, my writing is being crazy. Milliequivalents per 10 mLs, okay? So if you have that, you just need to simplify it down to 1 ml, right? So anytime you see that with extra zeros in there, you just cross out the zeros to what you don't need. So it's actually 2 milliequivalents per mil. Does that make sense? It's like going back to, I don't know what grade math that we learned, simplifying equations, right? Where you cross out the zeros you don't need. Maybe like 4th or 5th grade math. I don't remember. So long ago for me, so old. So now that makes it easier to work with, right? So now we have 2 milliequivalents per mil. So we take our 15.4 and we divide that by 2 milliequivalents per ml. And what do we get? $7.7 mils. So what's important to also know? Good. We divided by 1,000. So very good. We divided by 1,000 here because 44 milliequivalents per liter. So we were taking that liter and we were solving for what it would be if we were looking at doing 1 milliequivalent per mil for a bag. So since a liter is 1,000 mLs, we took 44 divided by 1,000 mLs to just get what it was for 1 ml. Yes, I know. Milliequivalents, we try to get out of our brains, right? But essentially milliequivalents, I mean, people say, oh, it's just like milligrams. I mean, it's a unit of measurement, yes. And we treat it a lot of times like it would be milligrams, but it is different because this is an electrolyte. So milliequivalents are used only for like electrolytes that we use. So if you look at it, like we use it for potassium chloride electrolyte, right? We use it for potassium phosphate. So anything that you see that is some sort of electrolyte, you're going to see it with a milliequivalent. So that's the reason why we use it, because it had some sort of electric charge at some point. So yeah, people just get freaked out when they see a milliequivalent, but you can kind of just take at ease that there's nothing really different about it other than the fact that it's an electrolyte. Okay, so does that all kind of make sense to you? So you can set the problem up either way that makes sense to you. So, that it is, that it is this way. Or you can, I always do it this way. This is kind of how I just did it in practice because it was easier to do in a calculator this way for me. And it made more sense. But it's kind of up to you. As long as you get the answer, right? And awesome. Any questions on that? Great. Okay. So our next one, you are told to start a liter of fluids at 35 mils an hour using a microdrip set. How much fluids will be given in 8 hours? And then what's the fluid rate in drops per second? So the first question of that is, and I like to do this because it freaks you guys out when there's 2 questions in there. So focus on one part of the question first, all right? And then go to the next one. So how much of those fluids will be given in 8 hours if we are starting our fluids at 35 mils an hour? So don't even worry about using a microdrip set. Great. So if we're taking 35 mils and then doing 8 hours, right? Yeah, it's 280 mils in those 8 hours, right? Perfect. Now, what is the fluid rate in drips per second if we are doing 35 mils an hour? How are we going to figure out our drips per second? Yeah, micro is 60 drips per. Okay. So if we do, yeah, in an hour, we have 60 minutes, right? And then in a minute, we have 60 seconds. So those two together would be 3,600 seconds, correct? I'm all about simplifying life here. So in 1 hour total, there is 3,600 seconds. All right. So now we just have to put our drip set in here. So you guys said drip set is 60 drips per mil, right? So if we look at our stuff here, we can cross out our mils and we now have drips per second. So we have done everything correctly. So now we can do our math. And we get all right. So how tell me how we are going to find the closest drip rate as possible without having to round too much. Okay, so if you multiply by 5, it gives you 2.9. Anyone else have an answer? I got something closer. But good job, Amanda. Ooh, good job, Sarah. Very good. Sarah did multiply by 7, and you get 4 drops per 7 seconds. See, don't you just love playing with your calculator? So multiply by 7 seconds, and you get 4 drops per 7 seconds. So that makes you just not have to round quite as much, right? So the reason for that is, especially when you have lower fluid rates, if you round too much, it changes your fluid rate at the end here. It will raise your fluid rate. So here I could have raised your fluid rate to even 40 mLs an hour. And so depending on, your patient, we could fluid overload our patient drastically, depending, and our patient might not be able to handle it. So it's important that we try our hardest to get it as close as possible if we have to do a drip set. And a lot of people go, well, we don't really have to do drip rates that much. And I actually just recently saw a practice that didn't have fluid pumps. So yeah, it still happens, so that we have to do drip sets. So very, very good. Okay, so this is another one that some people had some problems with. And so we can do a couple ways for you. But we'll just do this one pretty easy for you guys. Your doctor would like to start a 10-pound renal cat on fluids at 2 times maintenance. So what's the mils per hour in drips per second? So first we have to figure out kilograms. No, not go the other way. Yeah, good. 4.5. And yes, these both have to be whole numbers. You are correct, because we can't, when we are doing our drips in practice, when we're doing the drips per second, we can't do decimal drips when we're doing those drips in seconds. They have to all be whole numbers. Good question. Okay, so 4.5 kilograms. And then what is our maintenance rate? All right, so 60 mils. And great, so 4.5 times 60 is 270 mLs, right? And this is for 24 hours, correct? So what do we do now?
Multiply that by 2 because you're 2 times.
Good.
Maintenance.
Good. So multiply that by 2. So we get 540 mLs. Very good. And then we are going to do what? Good. Divide by 24. And you guys get 22.5 mLs per hour. Awesome. So that's the first part of our problem. And then we're going to go to drips per second again. So again, we go 22.5 mLs. And then why don't you guys do this part and let's see what we come up with. And then remember our macro and micro. And yes, Sarah, we can do that, actually, the other formula as well. That was kind of what I was saying in the beginning. I'm like, oh, we could do this a couple different ways, but yes, we can absolutely do that way as well. And that's actually a more accurate way. So, you got it over there. It was more of a conversation with myself. But no, you're fine. Very good, guys. Yeah, so this one worked out really well, actually. So, all right, let's. All right. So, someone talk it out for me. Tell me what you did. Don't be shy.
I did the formula that you have there, the 22.5 divided by the 3600, and then multiply it by 60, and then I kept going until I got a whole number.
Great. So you use your calculator.
Mhm.
Great. Awesome. In school, I learned that maintenance is kilograms times 50 mLs per day. Is there a difference? Okay. So here's the deal. Technically, Sarah has the maintenance formula that we really should be utilizing for cats right there. And then dogs is slightly different with where we multiply it as 132. So technically it is for cats. Sarah, hit it. Tell us what it's 80 times our kilograms to the square root of 3/4, essentially, right? And then for dogs, it is 132 times kilograms to the square root of 3/4. Now you will see, so the reason why we use this is because it's the most accurate for body surface area. So for body surface area, okay? And so we should really be using this. I will do some problems that, so you guys get used to like this formula itself. Now, the problem with this is that I have heard for the VTNE that they do not give you guys calculators for the test that you can utilize like the square root function. So that makes it difficult. So the other part is that everyone has learned previously that maintenance is between 40 to 60 mLs per kg per day previously, right? So your instructor probably just picks somewhere in between to let you know. Oops. But yeah, typically normal for dogs previously was always 60 mils per kg per day. It's always dependent on your doctor that you work with, of what formula they want to use or what they want to do. Whenever I've worked with like internal medicine doctors and stuff, they have used this formula. Typically when I've worked in emergency, they have done like 60 mils per kg per day, just because it is fast and easy to be able to utilize. And then we've always used our shock doses as well, which, do you guys know shock?
90 for a dog, 90 ml per kg per dog, and then cats is 45.
Okay, so 90 mLs per kg for dog. Cat, oops, dog. Cat would be 50 to 55 actually mLs per kg for cat. So, and the reason why it's this actually is because this is their blood volume. So yeah, but great question. So yeah, we'll do some problems like with these guys so that you guys know how to do these, because they're a little tricky. So great. Which we could probably do it on this. So, okay, let's skip this one for now because it's long, but we'll come back to it. And let's do our solution one, because I know you guys had questions on a solution. Okay, so you're instructed to make a 24% solution using 90 mLs of sodium chloride. Your stock solution is 84%. How many mLs would you need of your stock solution to make 24% solution? All right, so now's the question. What formula do we use? Our infamous formula that we all love, right? Yes, our C1V1. Everyone loves it. So I always fill it out like this because I don't know, it's like my safety. I've always done this. I don't know why, but it's just my safety thing. Great. So now we just fill in our steps. So for some reason, I always put my like stock stuff over here. And then this is like my final product over here for some reason. So just what I do, I don't know. So if we are instructed to make a 24% solution using 70 ml, so let's just take that part right there, right? So we then put our concentration 24% over here, right? 24% with 70 mLs, right? That's what we have. Or that's what we're gonna want to make, right? Our stock solution though is 84%. And then it says how many mLs will you need of the stock solution, right? So we know we have for stock 84%, but we don't know how many mLs of that stock solution we'll need to put in for the 70 mLs. So does that make sense how we set that up? Yes? No? Okay. So now we just need to simplify it. So we have 84x, and then we multiply our 24 times 70, and we get 1680, and then we divide that both sides by 84. And we get x equals 20 mLs. So that means that we need to take 20 mLs of our stock solution and put it into the 70 mLs of our total sodium chloride, right? So here's the question. our total is going to be 70 mLs, correct? So if we are taking 20 mLs of the stock solution, what is our total of our new solution going to be? Ooh, you knew it. Remove the 20 mLs first. Yes, good. Good, good, good. So yes, our total should always be just the 70 mLs. So we take out 20 mLs of our final solution first before we put in that 20 mLs of stock solution, right? Because we'll just dilute it down even more. So it really won't be 24% if we put that 20 mLs in there and then make it 90 mLs. We don't want to do that. We want it to stay at 70 mLs. Very good. Very, very good. So it'll be 50 mLs of your saline and then 20 mLs of the stock solution. Great. So the same thing goes for, like, technically when you make anything. So like this one up here for your KCl, you take 7.7 mLs out of your 350 ml bag first, and then put in your 7.7 mLs of your KCl. I know it sounds silly, but that would make the appropriate concentration if you did that. Otherwise, it's just slightly changes it. All right, let's go on to the next one. Okay, so this one is interesting. So if you have a patient on 4% isoflurane and your fresh gas flow rate is 1 liter per minute, how much oxygen will your patient get per minute? And how much isoflurane will your patient get per minute? This is an interesting one. See how much you guys know about your vaporizer and your flow meter. Anyone know how to set this up? No, good, okay. Anyone know how your vaporizer or your flow meter work? Yes, good. How does it work?
You mean like starting from the hose and
Yeah.
how oxygen has to be pushed, oxygen has to be used in order for the ISO to work.
Yeah, absolutely. Right. So the oxygen goes through the vaporizer, right, to pick up the gas anesthetic, right?
Mm-hmm.
Good, good. So if we have oxygen that's flowing through at 1 liter per minute, 4% of that gas that's going through, or 4% of that anesthetic gas from that oxygen is going to be anesthetic gas. Does that make sense?
Yes.
Good. So does that help you guys try to figure out that problem? A little bit. So,
Okay, so 100%. So we just minus 4% from 100%.
So yeah, if you had, so take your liter, right, and change it into mils, right?
Yeah.
So 1,000 mLs per minute is oxygen. If you had no gas going, or no gas anesthetic, I should say, going, if that was going through, except you have isoflurane. So 4% of that though, so times 4% of that is isoflurane. So if you take 1,000 mLs times 4%, so 0.04% of isoflurane, how much of that is isoflurane?
40 mils.
40 mils, good. So 40 mils of that is isoflurane per minute. So how much then is technically oxygen now? Just subtract it, right? 40 mils or 1,000 mils minus 40 is O2. Because you only have 1,000 mils going through. Right? Awesome. So this is important to know because people like to turn up their oxygen flow meter all the time, right? So say you turn up your oxygen flow to 2 liters a minute. And now you've doubled your isoflurane, right? So it's important that even though you may be turning your isoflurane down, you also keep in mind that your oxygen is flowing pretty high as well. So that you maintain your oxygen flow at a decent rate as well. So that's why we go over, you know, oxygen flow rates, not only just to keep your patient warm because oxygen is really cold, but to also make sure that you are maintaining anesthetic gas at a good rate as well, so that we don't overdose them, right? So it's just like if you guys were giving a propofol dose, we don't just like give them crazy amounts of propofol for the fun of it, but because there's an actual dose for it. So we want to make sure that we maintain them at an appropriate dose as well. So, and we see it in practice all the time where we have huge amounts of isoflurane going because of oxygen flow rates being high, or people just turning everyone on the same ISO rates all the time and oxygen flow rates. You know, just like a Great Dane and a Chihuahua being on an oxygen flow rate of 2 liters per minute and 2%. That poor Chihuahua is being overdosed, right? Will these questions always per minute? Yes, yes. So your oxygen flow is in the form of mils per minute, or I should say liters per minute, right? So like how it is measured is in liters per minute. So it should be worded that way, if that's helpful. Okay. I'm glad that helps. Okay, so this one is you guys are preparing for surgery for the day, and you turn on your oxygen tank, your H tank, and notice that the tank is only at 700 psi. How many liters remain? You are maintaining your patient at 1.2 liters per minute, and how many minutes are left for that? So Great. So did you guys learn this as well in school? Yes, good. Good. No, okay. So, all right, so you have two main tanks that you guys utilize in practice, right? So you have your H tank and your E tank. All right, don't laugh at my H tank and my E tank. But your H tank are your really big tanks that you have in practice, right? So H meaning huge, E meaning emergency. So that's the way that you can remember it. So your huge tanks are the ones that are really hard to move. They carry a lot of oxygen for you. And the emergency tanks are the ones that you can hook up to your anesthetic machines. They're portable, that type of thing. So what we need to know about them is that when we have measurements of them, when they're completely full, both of them are measured that they are full at 2200 PSI. All right, so this one is 2200 PSI. Now, when they are completely full, because the H tank is huge, there is 6,600 liters of oxygen in that tank. All right. The emergency tank, because it's so much smaller though, there is 660 liters of oxygen in there. So that's the huge difference. All right. But they still have the same amount of pressure of oxygen in there. So we came up with a constant to use for when we're going to do our problem coming up. So what we do is we divide these two numbers together, and it comes up with our constant. So these two numbers divided together are 3. Well, it's technically 3.3, but we're using 3. So that's our constant. All right. This as well, it would be 0.3. Okay. So those are our constants that we use for when we are going to be utilizing this next part of our problem. So that is kind of the concept to what you guys need to know about these tanks, at least for this. So when you get into practice and you turn on your oxygen each day, there's like a little manometer gauge that you look at. And so it'll tell you, like, you know, when it gets to 500, you need to change out your tank because it's pretty empty. But if it says, this one says 700 PSI, you need to say, okay, how many minutes am I going to have left? Can I get through surgeries today? Because you definitely don't want to get to the point where you're trying to change oxygen during the middle of surgery. That gets too hectic. So if we have 700 PSI, you take 700 PSI. And since this is an H tank, we take our constant 3 and you multiply 3, and we are going to get an answer in how many liters we have left in our tank. So we multiply that together, and how many liters do we have? Good, 2,100 liters. Now, we are going to be maintaining our patients today roughly on average of 1.2 liters per minute. All right. So the next part of this is we're going to divide this by 1.2 liters per minute. And this is going to give us then how many minutes we're going to have left, because this crosses itself out. All right. So if we have 2,100, divide that by 1.2, how many minutes are we going to have left? Good. So we'll have 1750 minutes. And then you can go into hours by dividing by 60 if you want to. So you have, 29 hours left. So you should be good for the next day or so.
Wait, I thought you divide by 24.
Well, first you need to figure out, because this is minutes.
Oh yeah, 60.
Yeah.
66.
And then you can, yeah. And then once you get to hours, then you could do 24 to find out days. But yes. Does that make sense?
So would it be best just to remember the 3 and the 0.3 as opposed
Absolutely. Absolutely.
okay, so forget about the 660 whatever. Okay.
Yes, but it's good to know where they come from, so like you don't necessarily have to, that's why I like to tell you like where these guys come from.
Mhm.
But in case for some reason they say on a test like how many liters on a full tank of emergency tank, or whatever, I'm sure you can pick it out of a multiple choice, or something to that effect. But it's nice to know where these guys come from rather than just memorize. I don't like you guys to memorize stuff. So that's not how I do things. So yeah. Now, if this was an e-tank, you would do the exact same thing, 700 PSI, and your constant would be 0.3, and you'd go this route. So you would end up with 210 liters, right? And then you would divide by 1.2 liters per minute. And you would end up with probably 175 minutes, I think. That's my guess. Correct me if I'm wrong. Yeah. I mean, I definitely would ask you some of these questions of like, if it were me for the VTNE, I would ask these questions too. But because they're easy. But to solve this problem, sure thing. Just remember this. You don't have to explain all of this to get these answers, So, all right. Okay, let's do my fun. We'll get to these next thing. Let me find my Mentimeter, and we are going to, I'm going to stop my, okay. So we're going to play a quick game for funsies. So you may need your phone. If you want to use your phone, you can use your computer too. We're going to play a game. So you're going to need to go to menti.com. And then the code is right here. It's 2647 6993. And I will say it's easier if you guys talk rather than type, because it's hard for me to see the chat during these things. So, but I will try to keep up with the chat. It's just hard. Yeah, you came in at the right time. Surgery. Oops. Look at the Canadians. Oh my gosh, everyone is on the West Coast. I got Midwestern, yes. Wow. I love finding out where everyone is. Then I know where to go to visit. Ooh, neighbors, look at that.
And where are you from, Beth? I don't remember what you said.
Oh, I'm from the Chicago area.
Okay.
I know. Not super exciting, but they have good food. I like to eat, so.
Which part of Chicago?
Like the outskirts. So, oh gosh, I'm like way west. So like, Aurora, I hate saying Naperville, but Naperville,
Mm.
closer to, I basically live in farmland, even though I say Chicago, but it's kind of the best of both worlds. So.
Yeah. I have family that live in Chicago.
Oh, awesome. Yeah, I like it because I can still drive to Chicago like pretty easily. I'm only about 35 minutes away, but
Oh, yeah.
then I can buy my produce straight from the farmer. So it's super nice.
Yeah, we moved out of Chicago. It's just too expensive.
It is really expensive. Yeah. Yeah.
Taxes. I was
Oh,
like,
totally. Yeah. I know. Where are you?
Right now I'm in Missouri,
Yeah.
Columbia, Missouri.
I
But
was just looking at practices yesterday in Columbia, Missouri, actually. So you guys are in my territory. So
nice. I just got a job. I'm actually, my start date is on the 28th of ER. They just opened up a Horton Discovery.
I was just looking at the practice yesterday. That's a really awesome practice.
Yeah,
How
so thank God we
exciting.
finally got an ER here.
Yeah, that's awesome. Yeah, I've been talking with them on and off for a while, so I'm really excited. Congratulations.
Thanks.
It's a beautiful practice.
I'm so nervous because I'm like, I don't have my license yet, but I'm supposed to take it. Well, I'm still waiting on the state to.
Yeah. Missouri is a tough state with licensure. So I mean, that's good. It's absolutely good. But that's really exciting. I know they have quite a few practices too. So it's exciting. How funny. I was just literally yesterday just looking at all their practices. So because I've been working with Missouri a lot technically this last week, but I mean overall the last year and a half as well, because I have Missouri, Iowa, Wisconsin, Illinois, and Georgia. So Georgia's my extended state. So awesome. Very cool. Oh, okay. So we got people all over. Very awesome. This is great. All right. So tell me what methods support your learning the most. And then obviously we'll go from there. See where you guys are all at. This is like honesty session. And these are all anonymous.
Definitely love the videos. Those help a
Good.
lot. Like seeing it helps.
I like to use a lot of other people's videos too because you guys get tired of hearing my voice. Plus, everybody teaches differently.
Yeah, those videos you posted made me understand the fluid rates better. Like there's actually a formula that I was using.
Oh, good.
That actually helped.
Picnonics too. It's funny because some other teachers now just found them recently. And I was like, I've been using them for all year.
What's funny though, they have Picmonics for all the other like
Yeah.
science and like medicine stuff, but we're not there. They don't got vet tech,
Yeah.
they don't got vet med.
Yeah, I know.
I sent an email to be like, hey, can you guys like make Picmonic content? I think
Yeah.
I'll
They need to have like an app, honestly, too.
Mhm.
Because I just joined, like, they have like a website thing that you can do that has even more videos than what we have, just to kind of check out their stuff. And they have a ton of stuff that you could do, all different subjects. I mean, their pharmacology stuff's the best.
Mhm.
But yeah, it's interesting.
What's
Ooh.
really cool though on that, I discovered that you can make your own Picmonic. So technically we could make our own vet med Picmonics and
Oh,
like
that
share
would
it
be
within the
good.
Facebook group. We can
I
send
need
you
to
the
check
link,
that
but that'd be pretty
out.
cool.
Yeah, I need to check that out then.
I'll send you the link because you can create like your own profile like via Facebook.
Yeah. Now
And
you
you
gave me
can kind of
something
like set
else to
goals
do.
and you get like badges if you have like a certain amount of quiz, right? It's pretty cool.
Now you gave me something else to do. Thanks a lot. But that would be really cool.
So I find Picmonics helped me a lot for pharmacology. Like there's so many drugs I was like, I have no idea.
Yeah.
And I'm like,
Oops.
yep.
Awesome. This is great. Yeah, the testing, active discussion, absolutely. Drawing is that's really good. Some people hate drawing. But I feel like me personally, sometimes the drawing can be even helpful. And I suck at drawing, but sometimes the drawing and then just puts it right in your mind regardless. So project based sometimes. So the funny thing about project based is that teachers don't know how to give you projects that actually make you learn. So you just have to get the right projects to make you learn. So you guys may have been gypped out of good projects. So interesting thought on that. And some projects are busy work, so
I thought the binder one was
yeah.
a pretty good project. My binder is almost full. I have so many notes and drawings.
Yeah, good. And truly the one for you guys, I mean, that one is totally based on what you need. So, making it exactly that notes that are going to help remind you on things. So you don't have to make it into a book where it's like you're writing paragraph after paragraph, but just recall things, right? So like say carprofen, like what makes you recall what carprofen's about, or what makes you recall what dexmedetomidine and xylozine's about, like just things that you can recall on. Or you're right, like just a picture of something, that you can draw really quick. So yeah, it can be very simple. So that when you take it into practice, then you can look it up really fast and then be like, oh yeah, that's right. So very good. But yes, certain projects are truly busy work, and that instructors, a lot of times they just don't know how to give a good project, and they're like, here, write an essay. That's not a good project. It's not going to be helpful to you. So writing as well. So yeah, writing papers, stuff like that can be difficult sometimes as a learning experience, but yeah, it can be difficult. Reading, some people learn straight from reading. We are a hands-on type of group, so reading can be really hard for us to study. And then and especially when we are getting ready to take the VTNE, we went to a school or did school where it was very hands-on, and then we go to study and we'll then grab onto our books and then start reading, and that's not going to be as helpful to us. And then peer, yeah.
What I found with reading is that I start reading and I zone out. So I
Yeah.
just read a whole paragraph and I don't even remember what I just read.
Exactly.
That's my biggest issue.
Yeah, that's my
Reading.
ADHD right there. So.
Yeah. Help me out.
Yeah, and then peer-to-peer problem solving. So this is really good if you guys work together or on our Facebook pages where, you know, it could be utilized so much better. I wish we got back to the, you know, I love that we chat about like the successes and stuff like that on our Facebook group page, but putting on there like, oh my gosh, I just saw this, or I am having a really hard time understanding this, and then having everyone go there and say, you know, this is how I remember it, or how you guys say, this is how I remember it by the tic-tac-toe method, like someone said, or whatever, just to try to help each other understand certain things. So you guys are great teachers to one another, you know, and if you can teach someone else that, then you absolutely now have learned, you made that full circle with learning something. So yeah, it's a great study tool if we know how to use it correctly. So very good. I like that. Okay. Oh, you guys already got to it. All right. So the hardest part is surgery, anesthesia monitoring and post-op monitoring. Okay. Is that mainly like values or them being up and down? Hardest part would be math, such as flow rates, medication doses, and even adding the fluid bags, CRIs. Oh yeah, balancing anesthesia and patient vitals. Awesome. Okay. And that can be helped with certain anesthetic drugs. Ooh, exotic surgery. Yeah. Ooh. Multitasking, yes, can be really hard. That comes with confidence and experience for sure. So, and a lot of this is just experience, so that's good. And truly, you should never feel 100% confident in surgery, right? Once you feel like super confident in surgery, then there's an issue, right? Because you have a patient that is really close to death. And so, you know, we always have to be on our toes. So that's, I mean, it's good to just always be aware of what's going on. So making sure you stay sterile. Yeah, absolutely. So making sure the area is sterile, that you're not breaking sterility, that kind of thing. Very good. Very good. All right. So we're playing the game now. Everybody, let's see what all your... Where is everyone? Come on in. Where'd y'all go?
Oh, I'm a plane.
Interesting characters. All right. All right. So the faster you are at answering, the more points you're going to get, but make sure you get them right. Oh, look at little mousey. I love it.
Do you have any math questions in this one?
Yeah,
I
absolutely.
get my calculator. Yeah. Okay.
Oh my gosh, this is hard.
Good job, guys. So what's the most appropriate to sterilize needle holders? Oh, good job. So easy, right?
Yeah, I don't know.
Think about it. Think about it. I know, super easy. Don't worry, they'll get harder. It's like Who Wants to Be a Millionaire? All right, think about abdominal incision.
Oh, I didn't even think.
Oh, good job. You guys are smart. Yes, a 10 blade, very good.
The video helped me for that one.
All right, let's see where everyone is. Oh, you guys are all different names. Okay, the
Dang,
magical rhino is number 1.
dang.
All right, this one's a little tricky. What's the benefit of placing an IV catheter except? Oh, good. Wow, you guys are so good. I usually give people on this one. Great. So administering enteral nutrition, because enteral is oral, like oral nutrition. Very good. Super smart.
I'm not good with these words. I'm sure I got that wrong.
Awesome. Very good.
Mm,
Very good. Yes, thumb forceps. So brown absence are thumb forceps. Very good. Let's see. Do we have any? Oh, I got some changes. Very good.
I actually drew these instruments out yesterday.
Great. Yes, you're right. So belt fours are used for abdominal exploratories as a retractor. Very good.
LPs, they have the hook, right?
Yeah.
Those ones.
All right. So question 9.
Suture material. Um,
Very good. So yeah, they are categorized as braided or monofilament, right?
Mhm.
So there are suture out there that do not have needles supplied on it, so you can thread a needle on it. So very good. Oh, this was a good one.
Oh, chest. Oh crap! I picked the wrong one. Dang. Yeah.
Very good. So yes, this one is a
Pneumothorax.
pneumothorax because subcutaneous emphysema is just under the subcutaneous layer. Pulmonary edema is just when there's edema within the chest. So we actually would give like Lasix instead. Ascites is going to be in the abdomen. So we could just tap the abdomen. And then a pneumothorax is when there's air in the chest. So we'd actually would place a chest tube there to get that air off of the chest. So very good job on that one. Ooh, Sarah, she's in the lead now. Awesome. Very good. All right, so what is this?
Declaw.
Hayward.
Dikla, yeah, very good. Ah, very good. Yes, so our Rochester caramels are used a lot, especially in space for that crushing action. Cryos are a lot like Kelly's, so these are just hemostats to clamp off, you know, any type of vessel, stuff like that. So this is our crusher. Looks like Sarah's gonna stay in the lead for the moment, but we're still pretty close. Oh, I gave you large animal. Great. So yes, it prevents uterine infections. Very
What's a
good.
Catholic operation?
It's like a procedure on the vulva.
Yeah, so it's a
Control.
procedure that they essentially do to basically clean out like the uterus to basically prevent any type of uterine infection. I think it's essentially after they have their full essentially. So
Interesting. Thank you.
great. Good. Not much changes there. So
Cat is what?
The cat is under anesthesia, and you notice the pupils are central and dilated. So the cat is what? Right in your response.
Mhm. Mm, mm.
Very good. So yes, too deep. Absolutely.
Oh, that's nice.
Let me check. Let me check the ones I need to.
What is real deep? I was trying to
All right. Good job, guys. All right, your doctor asked you to administer 5 grams of 25% mannitol to a patient. How many mils do you give? Awesome. Good job. So yes, 20 mLs.
Thought that was a guess. I did 25 minus 5, and it gave me 20.
Great. So yeah, if it is, so if you guys know, like, right, you guys say you need 200 and this is 250 mil, or I'm sorry, 250 milligrams per mil, right? 5 grams would be 5,000 milligrams. So divide that by 250 mLs. That's 20 mils, correct?
Mhm.
Very good. All right, so the concentration of furosemide is 5%. How many milligrams are in 0.5 mLs or a half a mil?
this is hard.
Good job. So yes, don't make it too hard on yourself. It is 25 milligrams because if you have 5%, right, it is 50 milligrams per mil and a half a mil. So you would take 50 milligrams, divide that by 2 because it's a half a mil, and that's 25 milligrams per mil, right? So your doctor asks you to start a fentanyl steroid at 3 micrograms per kilogram per hour for a 50 kilogram dog. The fentanyl concentration is 50 micrograms per mil. What will the mil per hour be? You'll kind of slap yourself after you figure it out because it's really easy when you insert everything.
I see CRR and immediately go. I get so scared.
Oh my God.
Good job. So 3 mLs per hour. Very good. So if you look at this, it's 3 micrograms per kilogram per hour. We have a 50 kilogram dog. So we insert our 50 kilograms in there per hour. And our concentration, though, is 50 micrograms. So when we divide the 50 micrograms, it crosses out that 50 kilograms. So we end up with 3 mils per hour. So it's a pretty simple problem for you guys.
I think what's confusing is when you see micrograms, then milligrams, and then kilograms, your brain goes, okay, what do I need to do?
I put 3 miles an hour and I still got it wrong. It said mine was wrong. I put a space. Maybe that's why.
Ooh. Oh no, insulin. It requires 3 units of insulin every 12 hours. If using a 100 unit per mil, how many mils should be given at each administration? Oh, we got some people good. So yeah, some people got it here. Good. Yes, so if it is 100 units in a mil, that means that in that 1 mil, we can fit 100 units in there, right? So if that animal needs 3 units, that means that 0.03 mLs would equal 3 units. All right. Good job. I'm gonna make sure. Okay, I got all of them.
I did 0.06 because I thought it was asking for the whole day.
Oh, for the whole day. Got
Yeah.
it.
What? Green don't work.
How was it 120?
So if you get 10 beats in 5 seconds, how many additional seconds do you need to get 60 seconds? Remember, we need 60 seconds, right? So what's our multiplication factor for this?
5.
So
12.
60 divided by 5 would be 12, right?
Mm.
So we take 10 times 12 and we get 120.
So this is an ECG method question.
Yeah, a little bit, but it's the same as doing our heart rate. Like if you did 6 seconds, you'd have to multiply by 10, right? Or if you did 15 seconds, you'd be multiplying by 4. So yep. All right. So sorry. Oops.
Gotta check on the seconds for next time.
Mm-hmm.
How many seconds do we need? That's where
All
I
right.
went wrong.
Yeah. All right. So you're adding 40% more to your 100 mLs. I'll help you with this one. All right. So what is your new dextrose concentration? That it was 5%, but what's your new dextrose concentration after making it from a 40%? You're adding 40% saline to it. Did anyone get it? Nope. Okay, that's one thing we can go over in our next session that we'll talk about is how we ended up with that. All right. Because that's a good one to go over. Well, you guys are all over that one. Awesome. Body surface area, very good. Yeah, so chemotherapy is always just in body surface area. Very good. It's the most accurate way. All right, last question. All right. So how do we make this? All right, so if a volume of a 1 to 25 dilution, it can be prepared from 150 mLs of stock solution is what? So we're taking that stock solution and we need to dilute it to a 1 to 25. Good. So we essentially take 150 mils and multiply that by 25 and we get 3,750. Because our 1 our one part is that 150, and then the 25 is going to be the diluted part. Let's see who's going to be our top person. Oh, Sarah, you get bragging rights for this one. Good job. Very good. Awesome. Okay. So we can come back to this at a different time, but I wanted to give you guys enough time to take a break and get some food, whether you're, I guess, on the West Coast, get some breakfast, brunch type of food. Take a break, and then yeah, we'll come back at 11:30 my time, and then do our next session. So